So we have Harsha, who is a principal solutions architect at Microsoft. He has extensive experience working with DocumentDBs. And we have German, who leads the Kubernetes team at Microsoft DocumentDB. So we are going to talk about this exciting new Postgres extension. And what's so great about it is that the engineering team from Microsoft, Yugabyte, and Amazon are working on this together. These are three names that you'd not usually see in the same slide. So we are all collaborating on this to build a truly open source solution. And with that, I'll hand over the clicker to you.
Sure. Thanks, Hari. So my name is Harsha. I'm a principal architect with Microsoft in the cloud native space. And I have German here, one of my colleagues, who is an expert in the document database. And also, he'll talk a little bit about some of the contributions that Microsoft is also making in open source.
Hey, hello, my name is Eichberger. I'm with the DocumentDB team. And basically what DocumentDB is an open source MongoDB alternative. So we are Mongo API compatible. And so you can use DocumentDB where you use MongoDB today. The difference is it's 100% open source. So it's under the MIT license, and so it's completely free. And the way it works is we have a Postgres extension, which implements the document functionality in Postgres. And then we have a gateway, which translates the Mongo API to the Postgres API. And once you put both together, you get DocumentDB. How did we get to DocumentDB? Well, it grew out of a Microsoft project. So we are running our Azure Cosmos DB Azure Cosmos DB for Mongo vCore is based on this system, and so it's production tested. And we open sourced that at the beginning of the year, and then we donated it to the Linux Foundation a couple months ago. And it's now 100% open source, and you see the people at the bottom who are helping us doing that. It's AWS and Yugabyte and a few more. We have sort of InBev and Rippling in there. So a lot of people.
And it definitely adds a lot of developer flexibility too, right? Like if you're using MongoDB drivers or API.
Yeah.
So
and also you can use Postgres, so you kind of all the stuff in the same database, which is nice. But let's talk a little bit about generative AI apps and how DocumentDB can help you with them. And one of the big things which happened with the NoSQL or with DocumentDB databases that we had vector search earlier. Because we don't have a set schema, it's much easier to integrate embeddings and vectors. And then we added a vector search to that. So DocumentDB itself, we have vector search, so you can use it out of the box for AI work. We are using the PG vector extension, which is based on HNSW if you're a vector search connoisseur. Memory, because it's dynamic schema free, it's really good for chats.
Chatbots, right?
For chatbots, yeah. So basically the chatbox, if you have a conversation, it can go any way. And so it's going to be schema free. Some people upload images and say, hey, what's that? Or upload documents and all those things. And so it's really good to have a schema-free document-based database so you can do that. Try that with something like a SQL database. Then you need to think ahead of time. Yeah. What will people are going to do with your chatbot?
How many rows and columns do I add? How many tables, right?
So exactly. And so that really the flexibility makes it really good to be the memory for AI. Now, this is the slide we probably are going to spend the most time on because those are all the GenAI use cases we can do with DocumentDB. So one of the main ones is RAG, the Retrieval Augmented Generation. So this is basically where you store additional data to help your AI to be more specialized for your use case. So people say it's like giving the AI a cheat sheet instead of doing the whole tuning work. And so basically, this is really easy to store in a document database because a lot of times what you give people are documents. So for instance, if you are an organization, you probably have written a lot of documents and you just throw them in the AI and then they can help you more company-specific things again. So that's why it helps.
I know we have limited time here, so yeah, if you want to go over these use cases, we are here after the call. So if you want to chat more about it.
Absolutely, yeah. So operational and semantic databases, what do I mean with that? So normal database, they store verbatim what's happening. A semantic database would store the meaning and intent. So you put it in, it distills it to meaning and intent, which is basically compressing it. And so that makes it reduce complexity and cost, because now it's compressed and AI can work better with that than if it has to distill every time you do a search or do something with it to it. Conversational history, I talked about that. Very important if you want to improve your chatbot, that you store what the chatbot does. And again, I said it's easy with a document database. You need it for auditing, you need it for improvement. Got to be careful with that. I heard of cases where chatbots said things which were wrong, and then people had to pay. And if you have records, then they can find more cases. So again, like with everything. Semantic caching. So the idea there is that again, we are doing meaning and intent, and we are caching that locally, so you don't have to go to the internet and find that. And so that's another thing where document database helps you. Again, that would be latency because it's locally, and also you pay less because you don't need to spend your tokens on doing it over and over again. And then lastly, and that's everybody's talking about at a conference, AI agents.
You cannot have a conversation without AI agents.
Can't have that without AI agents. So basically, there are a bunch of things you use databases for with AI agents. Is the session history. So the AI agent doesn't forget and starts again, which is, if you work with it, a problem. And so can throw it into a document database, then it goes there. Then the other thing is transactions. So right now we see a lot where it's only one agent, but as things progress, we will have multiple agents working together, and then you have transactions, and they will not agree on something, so you have rollbacks and all those things. And we feel that doing that in a document will be better because they can all work on the same document, and when they're happy, committed. Whereas if you do it in a more relational way, then the roll back, and no database is good of that. Most database are optimized for basically writing, not rolling back.
This is where the memory aspect really comes into picture.
The memory aspect and the transactions. So they would work on the same document, and when they are happy, they agreed on it like humans do. They send it back and forth, and they say, that's what we agree on, then they save it.
Yes, exactly.
Whereas if you do it relationally, it will say, this is my opinion, that's my opinion, and no solution, roll back, start again. Roll back, start again, and that will break you. So anyway, last, why are we here? So why did I pay my flight? So we just open sourced on Wednesday the DocumentDB Kubernetes operator. So we donated that to the Linux Foundation. You can download it, you can use it. And basically what we are trying to promise here is you can run anywhere. You can run it in the cloud, doesn't matter which cloud, not just Azure. We tested on AWS and the Google Cloud. You can run it on-prem. We have that. You can run it on the edge. Wherever you need DocumentDB, operator runs it for you there. And so we haven't. So basically, a lot of problems is how do you network those things? We have Istio built in natively, so it will automatically network. Not the best performance, but at least it works. And we're also using Azure Kubernetes Fleet Manager. So there's some Azure stuff we need. And basically, why would you do that? As I said earlier, it's a proven engine. DocumentDB underpins our Azure Cosmos DB for Mongo vCore service. And so it's in GA, it's production grade, it's not something we just streamed up, it's running. And then also we put it to the Linux Foundation, it's truly open source, there's no strings attached, you can have that. We don't even own any copyrights anymore. And the other thing, it's as we said, we have a lot of people in there, and one of them is Hari, which I want to welcome back here. Yeah.
I'll go there. Thank you, folks. So, huge thanks to Microsoft for donating the DocumentDB extension to the Linux Foundation. So, how does Yugabyte come into the picture here? Right? This slide you'd recognize from the keynote. And the story is 9 years back when Yugabyte was created, we wanted it to be the best distributed database. And from the start, we knew this meant it had to support different APIs. So it had to be multi-model. And in order to do that, we built the DB in 2 layers. There is a distributed transaction and storage layer down below that takes care of, it's got graph replication, the failover, sharding. It essentially lets you run on multiple nodes, multi-node write, horizontal scalability, sync replication, like zero RTO, zero RPO, right? All of that stuff is in the lower layer. And on top is a pluggable query layer. It's all stateless. And initially, we came up with the YSQL Cassandra API, and then the Postgres-based YSQL API. Now, we have Postgres, and we have Postgres compatible. There's a Postgres extension. So with DocumentDB, we have the Mongo API on top. The great thing about it is all of this runs on any cloud. It runs on Kubernetes, it runs on-prem. Wherever you want to deploy and run it, all of this will just work. So stepping back, right, why do we have to be multi-model? Why do we keep saying that? It's mainly for developer flexibility. Because you don't want the entire company to say, hey, use one particular kind of database. You don't want everyone to use Cassandra or DocumentDB. Developers want the freedom and flexibility to choose the best API for their team and their service. And not just that, right? With the new AI-based world, people are writing applications at a faster rate, but also rewriting them even faster. And these things means you need to be able to switch from one API to another. So you have to future-proof all of these hybrid workloads. So if you do this with different databases, now we have database sprawl. And having it all under one umbrella, under one product, means we make everything easy for you, right? It's one system that you go deploy, one system that you have to do security patches on, OS upgrades, one thing that you have to know how to do backups on, your DR drills, procurement, all the runbooks, all the training for the operational team is on one product. And the application teams on the same product can choose which API they want. And also, last but not the least, any API you pick, well, you're going to need high availability. You want it to be geo-distributed. You want horizontal scalability, right? It's not an API problem. It's just these fundamental problems you want to solve. So let's look at how it all comes together. Right? So this is the architecture of the open source DocumentDB. So you take your existing Mongo application, and the point is you don't touch the app. Keep the app. Send it through the gateway that we just talked about, which converts the product wire format from the Mongo one to the Postgres one. Because Postgres, being Postgres, talks a particular way, and you need the thin stateless gateway layer that just translate the same API over. Right? So the API, underlying API is the same thing. That goes to the DocumentDB extension. And Postgres is also a database, so that also naturally has a query layer and a storage layer. So when we built YSQL, we took the Postgres storage and transaction layer out and put our distributed storage layer in. So since the DocumentDB extension is sitting on top, it just naturally works. Right? There's not much we had to do to get the extension to work. Right? So now that the extension is working, what do you get out of it? Right? So it becomes a truly distributed DocumentDB. You get HA, you get sharding, auto sharding. In this example, T1, T2, T3 are 3 shards or tablets as we call them. As the data set size grows, we'll automatically split them into more. We will place the data on every node. You add more nodes, the tablets move out to different nodes, and we'll put the leader of those tablets on these nodes. And if a node goes down, we'll rebalance. All of that just works with DocumentDB. What else, right? It's open source. It's still open source because Yugabyte is open source, the extension is open source, it's all open source, and everything remains open source. You get all the other enterprise-grade features we have for our Postgres API, including backups, instant cloning, restores, you name it, right? Follower reads, upgrades, downgrades, connection manager, right? We have an inbuilt connection manager to help with scaling connections. and the pluggable PG vector. Like German mentioned, the DocumentDB uses PG vector, and the Yugabyte PG vector is pluggable. So we can replace HNSW with usearch or anything else out there. All of that just comes in and works for free. And we have our own Kubernetes operator, which also just works. Right? By packaging it, all of this also comes into play. So I'm going to show a demo on this one next. So it's going to be a wide-coded game, right? And I'm using Cursor for this. And we're going to use, of course, DocumentDB on Yugabyte. It's running on Azure, but I can pick any cloud. But I picked Azure for this example. I'm also going to run some ad hoc queries using Mongo API. And then there's, of course, an AI element to it, right? So let's start this. So I wanted to build a game. And I'm a database engineer. I know nothing about game development. I barely know about front-end. So what did I do? I just went to Cursor. Cursor is the tool I know. I went to Cursor and said, hey, build me something. Right? And it did a very wonderful job. It came up with all of this stuff, which is great. It did not run. It had a bunch of errors. But the good thing was I was able to feed the errors back to Cursor, and it just fixed it all up. And it did work. At the end of the day, it did work. I didn't have to make a single line of code change. The only thing I did change is in the Docker YAML file, because I told Cursor, build it for Mongo. And then I said, well, let's take the Mongo container out and instead use this endpoint. So, of course, behind that endpoint is a Yugabyte cluster. It's not a super big one. It's just a tiny 3-node cluster with 2 cores. I don't expect a million people to be playing my game, so I can start small. I can start with 3 nodes. It's on Azure US East 1, 2, and 3, so I'm on 3 zones. Right? So off the bat, I have zone resilience, and I think these are 2 core machines, so very tiny, and as I grow, I'll add more nodes or bigger nodes. So in order to make this demo a little bit more real, so what I'm going to do is go to the US East 1 node on Azure portal. Let's see. And it's US East 1, so as you all can expect, I'm going to just go take it down. Right? Now, taking down this one node is fine. US East 1, everyone knows it's going to go down. And we'll stop the VM. So this is directly from the Azure portal. Just go hit stop. And that should take the instance completely down. And if we go in there and look at the Yugabyte cluster, this was before, I forget, there you go. As soon as I refresh the screen, you can see that the leader count in here, that goes to 0, which means as soon as that node went down, all the tablets, they moved off to the other 2 zones. So my database is available. There was no outage when I took that region down. And it's still showing red because it's waiting to see if it will come back up. If I refresh, it's 23 seconds. It hasn't talked to us for a while. That node isn't coming back. We know that's dead. So let's go look at the game itself, right? Yeah, look at all the graphics, all of that Cursor did it. I have no idea how to do any of that, right? It's a pretty simple game. You go around, collect these bugs. As you go do that, you can see that the score and the level up there keeps going higher. And you can, just keep playing it. You can keep hopping around, jumping around. The main thing I want to see is this stack here, right? These are the calls that all the application is making to the database. And this is the Mongo API that's getting sent in. You can see that as I was moving around, the scores are going higher and higher. And it's storing those scores in the game as I change things in the game, right, as I play it. And I can open up the database directly from Mongo Compass. So let's go there. Give me a second, yeah. So the scores go up and also the levels go up. I think if once I collect all the bugs, the level just bumps up. It's not a fancy game, it's a simple one. So this is the Mongo app to go look at the Mongo DBs, and I can just connect it to the same cluster. And I can see that my player, the score 190, just reflects on this one too. So there I have the levels and scores. I have different players in here. So now the next big question that I have again, right? How many players are playing it every day? I have no idea. I'm not collecting the stats. The only thing I have is the score and the level. I need to know how many people are active every day. So on a typical SQL like DB, the way to go do it has to go make an alter table, add column, backfill. I'm not going to do any of that. I'm going directly to my app, adding a single line saying last update, set the time, rebuild my containers. So one line in the application itself, right? And let it redeploy. And I just keep going and playing the game. I don't even refresh the web page, right? I just keep playing the game. And it's now sending the new ones with the last update date over to the database. So I had to know no schema changes, right? And it just reflects back here. And I didn't have to do alter table, I didn't have to do backfills, all of that stuff is gone. Now, how do we do an aggregation? Right? We can do a pipeline stage. First time I tried, it did not work because I'm vibe coding it all. I said last played, it said last updated. So this is one thing that I found with cursor. Each time you do it, it comes up with its own unique name. So pick the name, put it back, and run the query. And there you go. 1 million people are playing the game today. Right? There is a lot of nulls in that. As those players start playing, that data will automatically get backfilled. Now, this is the amazing thing about being in the document data model. Right? There is no structure, there is no schema. I can keep changing it. I can add more things on demand. Okay, what else do we have? We have one more thing in this game here. So if you look at the far end, there is this fancy Yugabyte icon thing guy. The plan is to have a lot of these games. This is just one game. And the same user can play multiple games. And I'm going to have an AI microservice that's running somewhere. And if I go to that character, it's going to give me an advice on how to play this game. The first thing it says is just a buffer thing because it's calling an LLM. I need to, that's my thinking dialogue. And then it's going to say, hey, you must go and, what does it say? Save the blue bug for the last, right? And if I switch to a different player, and I don't have a login screen, I just said pick players. Who needs logins? So this player is going to say 3 bugs in 3 seconds. Right? It's going to say you have to go collect 3 bugs in 3 seconds for you to advance in this game. Now, why am I getting different results for each player? If I go look on the right, you can see what it's going and doing to the DB. The first thing it does is get the player statistics. It's finding out who this player is, what they're doing in this game. And then the AI app is actually making a SQL query. In this case, it's a Postgres PG vector call to a table with an embeddings, and it's scanning through it and finding walkthroughs. It's going to take the walkthrough, the most relevant walkthrough, and then the player stats and feed it to an LLM and say, hey, generate me a text in that Yuga-like format. Right? So what is in the walkthrough? How is that working? And what is the data that I'm training it on? In reality, it could be anything. It could be YouTube videos of people putting walkthroughs. It could be PDFs, text, and documents. For this simple demo case, I have a simple table with just text. And we can go look at the table directly. Give me 1 second here. Yep. And this is the YSQL app. So I'm just doing a SQL query on it. I know for this one, the ID is 1. And if I just dump the text out, you can see that levels 10 to 20, the walkthrough said you have to do 3 bugs in 3 seconds. And then if I go to level 20 onwards, you have to go get the blue bug at that. So this is the raw text that's getting fetched and fed to the LLM along with the player's level, score, and all that information. And then it can stitch it all together to make it a seamless user experience. Right, so that was the demo. And what else, right? What are the next steps? What are we going to do next? So it's all a community-driven project. We have a big technical steering committee with Microsoft, AWS, Yugabyte, Rippling. All of us are working towards it to get it more community effort. And then we will build features based on community asks. So we have a Discord channel. So if you have any requests on what you would like to get built next, you can just ask there, and that's what the community is going to work on. The first order of business is to get 100% operator compatibility with Mongo. Right now, it's sitting at 90%, which is pretty good, but we want to aim and go for 100%. And of course, after that, it's all going to be performance, right? Performance, debuggability, tuning, it's the usual stuff you'd expect with databases. And there's some QR codes if you're interested on how to use the DocumentDB extension with Yugabyte. and the DocumentDB GitHub repo itself. They should also have links to the Discord channel on how to contact us back.
Okay, want me to go back and answer questions?
Thank you. We do have some questions.
Okay.
All right. Was there any latency observed in translation and limitations that folks need to be aware of?
Would you be able, or I can answer it.
Yeah, you can start
The
answering.
gateway is a very light and thin layer. It's only doing the wire protocol format conversion. It's not actually doing any query passing or repopulation. So there is no big latency impact. Also, the gateway is running on the same node as the database. So there's nothing much going on in that. So no, there's nothing noticeable latency in that.
Yeah,
Great.
I should probably, so usually people ask about latency, they usually go into the performance thing. And the big thing is, so, and then often people ask us, so how does this compare with other databases? And I mean, I always say it depends, it's workload dependent. And so if you're worried about latency and all those things, then you need to do your own tests and then tune things accordingly.
But while you were porting this, and making it your own thing, how does DocumentDB performance compare to Mongo?
I know this is so as I said, it's workload dependent. So it also depends on the stack. So I can talk about the stock Postgres stack. So we have if we do just the normal Postgres underneath, we can in the right circumstances our point read point write can be faster than Mongo. When it comes to operators, depends on your workload how it turns out. I don't know for the Yugabyte case if you have.
It'll be very similar, but also the aim of the next steps in the project is to be performance. It is to be as performant as Mongo. So yeah, it is being worked on.
Right. So can you use read replicas with DocumentDB?
I guess there's a question for with Yugabyte. I guess so. Yes. You don't have to. Yes, it's there. Yes, you can. I don't think we have a blog example for it yet, but yeah, we can put something out and you can use it.
Yeah, if you have suggestions of what you'd like us to put out for guides, please just let us know.
Yeah.
Any of the team. So thank you all so much for coming up and sharing with us today.